All right, so I'd like to give you a little bit of a helpful hint on even and odd functions. First, if you were researching for this on your own and you went to Khan Academy, which is one of my favorite places, and you searched for something, maybe you had a textbook and you found out that odd functions are symmetric about the origin, you might have searched for that, and you might have found a video. Actually, one of my favorite videos is this one. Odd functions is around 5:45 in this video, but and they do a great job of explaining a lot of different things in here. So I encourage you to go here to watch that. But what I'd like to add is a little bit more using Desmos and just kind of looking visually at graphs of functions and kind of visually investigating them a little bit further and more of a general case. Because right now, he gives you a few examples, which is fantastic. But let's just talk about if we generalize that, right? So with even functions, I think in many textbooks, I don't know about your textbook, but the one we're using in class, one of the first examples is this one. It says determine if it's an even or odd function. And the example is this, right? X squared, y equals x squared minus 5. It might even say f of x or g of x right here. And just by looking at this, especially if you watch that video, you first hopefully you recognize it, but you should also see that there's some symmetry here. The graph is reflected, it's got symmetric about the y-axis, and that's what it means to be an even function. So if it's even, it is symmetric about the y-axis, and there's a formal definition for that, and I'm gonna go through that and show you that after I do these. But what is kind of more important is if it was plus any number down here, so let's say it's a, what we can do with Desmos is add this little slider. So if a is 1, it looks like it's symmetric about the y-axis. Well, what if a changes its value? So kind of more of a general case. If I scroll through that, so a is changing here, so the value of this is increasing or decreasing, right? It's always going to be symmetric about the y-axis in this case. If you have a simple quadratic where it's just x squared plus a. And actually, I probably should have used a different variable there. Maybe I should have used b, because typically you'd have an a out here, right? Ax squared plus bx plus c. That's standard form. So if I had sliders for all these, then we can ask the question, well, will all quadratics be symmetric about the y-axis? I mean, right here when we have b is 1 and we go forward here, I can already see, no, it's not. So what if the value of b changes? All right, well, certainly when the graph's moving, these are transformations of functions. When it looks like when b is 0, let's see if I can make it 0. It looks like it's gonna be, right? Because it doesn't matter what a is, that's gonna change the shape of the front of it. So if this middle term gets taken away, like 3x squared or something like that, or 7.91x squared plus 0x plus anything for this is gonna move it up or down, is not gonna change whether or not it's even or odd. So that's not going to give you the answer right away. You're not going to, if this is a test, you're not going to magically go, oh, okay, I'm just going to go on Desmos and sit there and show you. But it should give you some intuition about which functions are going to be even or odd. So it's not automatic that just because it's squared, it's going to be an even function, right? And likewise, if this was cubed, so this is to the third power, ooh, fix that. Third power, I can get rid of these sliders here. Actually, I should probably add that one in. If I add that in, is that an even or odd function? Well, if you remember the definition of odd, it's going to be that negative f of x equals f of negative x. In other words, it's symmetric around the y-axis and the axis. Or another way to say that is that symmetric around the origin. So odd origin. So they both start with the letter O. That's one way to remember it. So if you have a point here, the negative x value of this will give you the negative y value. That's the output. We'll show you that algebraically, but looking at this one, what will change? Is it still going to be symmetric around the origin as a changes? And it looks like it is, right? What if we have plus b in there? So let's add the slider for b in there. I wonder what will that do to the problem? And you can do all this stuff with your home if you've got your computer there. It looks like it's just shifting it vertically. And I may have spoke too soon when I said that it is there. Maybe I didn't look. Was that going through the origin when I spoke earlier? I may have made a mistake there. But it is when it's going through the origin. But here, it's not, right? So this is not symmetric about the origin right now, because if you reflected that around the y-axis and then the x-axis, you wouldn't get the same graph, right? Or you wouldn't get that reflection. So what you have over if you reflect it over the y-axis and x-axis, it wouldn't be a reflection there. So you have to be careful. If this was a squared, it would be even, right? But the second you make it a cubed, it's not. What happens when you make it a fourth power or a fifth power, right? Things start to get changed. So then at that point, and especially if we start to get really complicated, like what if we had bx squared plus cx plus d? Well, man, now we've got all kinds of different things. So we have all these different values. When is it going to be even or odd? It could be really complicated. And that's just, we could also have, what about 1 over x or 1 over x squared? And this is what's tricky about pre-calc, right? Is we do everything, we investigate functions just like we did in second year algebra, except now they're just so much more complicated. So what we need to do, we need to have an algebraic way of manipulating this because you're not going to be able to necessarily see from just the graph. You can get some intuition about it, but what we'll do next is we're going to look at the graph, or I'm sorry, the algebraic version of it.
All right, so as promised, we're going to look at even and odd functions algebraically. And so what that means is we're not looking at a graph, obviously, but we got to have a little bit of a better definition of what it means to be even. So a function is even if and only if. So even if and only if. And if you might see this in the Khan Academy, that means this right here. That's this little symbol right here. Even if and only if f of x equals f of negative x. So that's what we'll check algebraically. And it's odd if and only if negative f of x equals f of negative x. So what we need to do is we need to check that the original function is the same as function when we have the negative x, right? If I plug in negative x, will I get the original back? And here is if the whole function's negative, will I get something back that's the same here? I guess it's kind of hard to explain in words, or maybe I'm just incapable of doing it. So why don't we just try it? So let's try example 1 and example 2. These were 2 ones from a textbook that I was using. So let's try this one. Let's say that instead of it being y equals, let's say that this one's f of x and that one's g of x. So f of x equals x squared plus 5. All right. So we want to check to see if it's even and odd. Check to see if it's even first. All right. So f of x, or negative x, we want to know if f of negative x is going to be equal to this. So what we'll do is we'll plug in negative x, and then we're going to simplify it. Okay, so negative x squared, well, that's going to be negative x times negative x, which is just going to be the same as x squared. You could also think of it as there's a negative 1x squared there, so the negative 1 is squared, and negative 1 squared is positive 1. And then the x squared is squared, so that's x squared plus 5, which equals f of x, right? So because this and this are the same, it is, in fact, even. And we actually already knew that because we did this with a graph, but that's how you would show it algebraically. That's what you check. So you don't really need to do much with this, but you want to check to see if this side equals this side. That's really all you do. And then we want to look at the next one. We want to see, okay, is this one even or odd? All right, so you could certainly check, and then really we're looking for the value of this in both of them, right? So if you first check to see if f of x, or I'm sorry, if f of negative x is equal to this, if it's not, then you know it's not even, but you could also then check to see if it's equal to negative f of x. So really it's a great place to start with even and odd. If just check to see if f of negative x either equals f of x or if it equals negative f of x. If it doesn't equal either one of them, then it's not even or odd. So let's just check with this one. And like I said, we'll use g of x with this one. So g of x, let's say g of x equals 5x to the third minus x. All right, so we're going to check to see what the value of g of negative x is. G of negative x is, I'm going to plug in the negative x here, and then I'm going to plug it in here, so minus negative x. Let's see what this equals if I simplify this out. So this is 5 is going to be 5, right? And then we've got negative x cubed. So that's going to be negative x times negative x times negative x, right? So that's a negative 1 here, a negative 1 there, and a negative 1 there. So it's definitely going to be negative again. And because we can pull that negative out, so it's going to be it's going to be negative 5x to the third power. And then we can go from here minus a negative, so that's going to be plus x. Okay, well that is g of negative x. That is simplified. That certainly does not equal the original because we have the plus and there's a negative sign there. Let's see if it equals negative of the whole thing. So to do negative g of x, let's see if this is g of negative x. Let's see if this equals what happens when I do this. So I'll put a negative sign out front, and then I'll distribute that all the way through. All right. So that's what this is negative. So if I distribute this negative all the way through, it's negative 5x cubed. And then looks like it's plus x. So according to that, it is in fact equal to negative g of x. So it looks like negative g of x equals g of negative x, which would mean that that is in fact odd. So unless I did something wrong, did I do something wrong here? No, it looks like I distributed everything right because this is equal to this. So that's the same. So that's good. That means that it is odd. It is symmetric about the origin. We could check that with the graph. You can kind of see it with the graph. That is how you would do things with checking to see if they're even or odd algebraically. Hopefully that helps.